In this public price model, one README edit costs 20 cents on Opus and 4 cents on Haiku. Same 30,000 input tokens. Same 2,000 output tokens. Same one sentence change. That is like hiring a principal engineer to rename a variable. But routing every easy-looking task to the cheapest model creates a different bill. The router needs 3 controls: classification, escalation, and verification. If the first attempt fails, the stronger model must read the context again and repair the work. In the failure case, $6.74 almost catches the $7.90 Opus-only bill. So the question is not which model is best. It is which task deserves which model, and when the router must stop gambling, we will price 36 tasks, break the router, and turn the result into a 9-line policy. Clear the 3 walls, and the strongest model becomes an emergency lane, not the default lane. GitHub Copilot auto now scores a task across reasoning, code generation complexity, bug diagnosis difficulty, and tool orchestration. It also watches model health. GitHub reports better token efficiency with no quality regression in its evaluations. That is vendor evidence, not our benchmark. Qwen code now exposes a smaller fast model and a fallback chain. Kimi code can bind new subagents to an experimental secondary model, typically a cheaper one. These are not identical. Qwen fallback handles capacity errors. Kimi assigns a second model to subagents. The pattern is still unmistakable. One agent no longer means one model. To price the idea, I built a transparent week of 36 tasks, 20 renames and formatting jobs, 10 documentation edits, 4 localized bugs, 1 cross-service refactor, 1 security and architecture review. The counts and token budgets are assumptions. The model prices are official. Run every token through Opus, and the week costs $7.90. The number is small because this is one compact basket. The ratio is what matters. Opus charges $5 per million input tokens and $25 per million output tokens. Now route routine work to Haiku, localize bugs to Sonnet, and keep Opus for the cross-service and security jobs. The model bill falls to $3.34. That is 57.7% lower, without pretending the frontier lane disappeared. A stable repository can go lower. If 70% of input is a prompt cache hit, the model bill reaches $1.75. Anthropic advertises up to 90% input cost savings on cache hits. Our 70% reuse is only an assumption, not a promise. Now break the router. Every Haiku task fails and repeats on Sonnet. Every Sonnet task fails and repeats on Opus. The bill climbs to $6.74. The savings shrink from 57.7 to 14.7. A cheap model is expensive when it creates a second full attempt. The first wall is scope. Formatting and documentation are bounded. A localized bug may need 1 service and 1 test surface. Architecture and security can cross trust boundaries, data models, and deployment systems. Route by blast radius and ambiguity, not by how short the prompt looks. The second wall is knowing when to stop. Escalate before a cheap model spends another full context window. Trigger the frontier lane when the reproduction is unclear, the change crosses services, tests fail twice, permissions move, or the diff grows beyond the declared scope. The router needs a budget and a stop condition. The third wall is verification. A cheap edit is safe only when a deterministic gate can prove it stayed cheap. Run formatting, focus tests, type checks, and a diff size guard. For authentication, data access, infrastructure, and architecture, add a specialist review. Model routing never replaces code review. Here is the practical route. Renames, formatting, documentation, and code search start cheap. A localized bug with a clear reproduction starts mid-tier. Cross-service refactors, security work, and architecture start frontier. Private operations may route local even when local is not the cheapest compute. Switch at task boundaries, new sessions, or isolated subagents. GitHub explicitly routes at natural cache boundaries because a mid-session switch can add cache cost without enough quality gain. The future is not 1 model per token. It is 1 model per well-defined unit of work. The policy fits in 9 lines. Default to the cheapest tier whose failure is easy to detect and cheap to reverse. Set a retry budget of 1. Escalate on expanding scope, failed verification, permissions, schemas, or architecture. Then log the routed model, tokens, retries, and final gate result. Do not stop using the best model. Stop using it by default. The cheap model handles work that is bounded, testable, and reversible. The strong model handles ambiguity, blast radius, and expensive failure. The best coding model is not your default. It is your escalation path.